Loci. A locus is the path followed by a moving point. It can be straight or curved. Let's look at common loci. The locus of a point at a given distance from a fixed point. If A moves such that it is always at a distance x meters from O, the locus of O is a circle. This is represented as shown below. The locus of a point that moves in such a way that it is always at a fixed distance from a fixed point is a circle. In 3 dimensions, the locus of such a point is the surface of a sphere. Second, the locus of a point at a fixed distance from a fixed line. Consider the figure below. The locus of such a point is a pair of parallel lines, both sides of the fixed line. In 3 dimensions, it is a collection of lines forming the curved surface of a cylinder of axis AB and radius d meters. This is illustrated by the figure below. Third, locus of a point equidistant from 2 points. Consider the figure below. PR is a perpendicular bisector of AB at Q. P and R are random points on the bisector. AP is equal to PB, AR is equal to BR, and AQ is equal to BQ. The locus of a point equidistant from 2 fixed points A and B is the perpendicular bisector of the line AB. Constant angle locus. An arc or a chord subtends equal angles at the circumference of a circle on the same segment. Consider the figure below. AB is a chord. Points P and Q move along the circumference. The angles at P and Q remain constant. The locus of angle P is the arc APB. The locus of angle Q is the arc AQB. Locus involving chords. As a recap, a perpendicular bisector of a chord passes through the center of a circle. A line drawn from the center and is perpendicular to the chord bisects the chord. Equal chords are equidistant from the center of a circle. An example: AB is a chord of a circle. Construct the locus of a point equidistant from A and B. As a sketch, we have the figure below. MN is a perpendicular bisector of AB. All points along MN are equidistant from A and B. The locus is thus the perpendicular bisector. Another example: M is the midpoint of PQ. Describe the locus of a point on M as the chord PQ moves around the circle. This can be illustrated by the figure below. In our solution, we can describe M in this way. M is such that a perpendicular to PQ through M passes through O. Loci of inequalities. We can and have used graphs to solve simultaneous inequalities. The same graphs can be used to describe locus in a Cartesian plane. For example, describe the locus of points such that y is greater or equal to 2, x is less than 1, and x plus y is less or equal to 5. Notice that each inequality has its own locus. However, we want a locus that satisfies all of them. The boundary lines are y is equal to 2, x is equal to 1, and x plus y is equal to 5. This can be illustrated by the graph shown next. The shaded region R represents the locus of the required points. Let's take further examples. POR is an isosceles triangle. Angle POR is 120 degrees. Draw the locus of a point Q such that angle PQR is 60 degrees. In our solution, if we take OP to be the radius of a circle, the circle will pass through P and R, and PR will be a chord. PR will subtend an angle equal to half angle POR on the circumference of the circle so formed. This is shown below. Example 2. In the triangle below, A. Draw the locus of all points equidistant from PQ and PR. B. Draw the locus of all points equidistant from P and Q. C. Find a point M equidistant from P, Q, and R. In our solution, the locus of points equidistant from PQ and PR is the bisector of angle QPR. B. The locus of points equidistant from P and Q is the perpendicular bisector of line PQ. C. Point M is the center of a circumscribed circle to triangle PQR.
I think one of the problems with math is if you aren't strong in it, you end up with weak spots in the foundation. And so if you want to build on that, if you want to go in and major in it or to do honors in it, you really do need a solid foundation. And so if you don't have it, if you've had a bad experience with math, you tend to sort of slough it off, and that's a serious mistake, I think. I believe with the right resources and help, most people can learn most of the math that they need to learn. But in almost any class that you go into, you need to make sure that you're at the starting point. People come in with different backgrounds, different preparations, and so you're not all on the first day at exactly the same place. And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university.